Example 8. The door frames used by a builder are of one standard height, 1.830 meters. The heights of men are normally distributed with mean 1.730 meters and standard deviation 0.064. Right, there's a lot in this question. I'm just going to deal with part 1 to begin with. Find the proportion of men that would be taller than the door frame. Okay, the door frames are fixed. There's not much we can do with that other than recognise that they are that height. But the men, they are normally distributed with mean 1.730 and standard deviation 0.64. So I can write this as a normal distribution definition. Mean first, and don't forget in your definition you have to put the variance. You can write it like that, so that's much better because it will prompt you into using 0.64 when we need it later on. So in our diagram, we are interested in the proportion of men that will be taller than the door frame. Door frame is 1.830 meters, so that's to the right of 1.73, and we are interested in those that are taller than the door frame. I.e., although it is asking for the proportion, that's the same really as asking for the probability of picking a value at random and it being above 1.83. So we are interested in the probability that x is greater than 1.83, and we want to know what that is. I can't deal with greater thans, so I have to turn the question round to be 1 minus the probability that it's less than 1.83. I then need to convert to standard normal. So my z value is my 1.83, take away the mean of 1.73 and divided by 0.064, the standard deviation. Graphical calculator, we are working out a normal probability, so that's NCD. Only change the upper value, which is 1.83 minus 1.73, close the brackets, divided by 0.064. So that's a z value of 1.5625. Write that in and then scroll down to find the probability. So that tells me it's 0.9409, and I'm going to do 1 minus that, so the answer is going to be 0.591, and that's my answer. Part 2 of the question. It's the same distribution, but this time we're finding the frame height such that 1 man in 1,000 will be taller than the door frame. If we go back, when it was at 1.83 meters, we had a proportion of 0.0591, which is 5.91%, or nearly 6 in 100 men will be too tall. If we're after 1 in 1,000, that's a much smaller proportion, so I'm going to need to make my door frame much higher so that the area here is much smaller. So this value of A is going to be the height of the door frame. So we want the probability that X is greater than A. 1 in 1,000 is 0.01. So we want the probability that X is greater than A to be 0.001. Again, it's a greater than, so we need to turn the problem round. So 1 minus the less than will be the same as the greater than. So we want then that the probability that it is less than A to be 0.999. We need to convert it to a standard normal Z. So take away the mean and divide by the standard deviation. And then I can use my graphical calculator. This time I know the probability, I want to find the Z value, so I need to come back out, distributions normal, inverse normal, and the area is 0.999, and execute, and that tells me my Z value is 3.0902. So that value here will be equal to that Z value. So all we need to do is times up by the standard deviation of 0.064 and add on our mean of 1.73, and it gives me a door frame height of 1.928 meters, which is taller as we predicted from what it was initially. The last bit of the question says the door frames are to be used in a department store. It is known that women outnumber men in the ratio of 19 to 1 in the store, and the proportion of women taller than door frames is 0.00069. Find the proportion of people for whom a door frame of 1.830 would be too low. So we're back at 1.830, so that was the very first bit of the question. We've got information that they've given us and information that we worked out in part 1. So I'm going to just summarise that in a little table. For the women, we know that there are 19 out of 20 of them, and their proportion is 0.00069. And the men, there is only 1 out of 20, so one of our ratio parts, and this bit was the value we worked out in part 1. This really isn't a normal part of the question at all. It's really a weighted means question. I've got 19 times more women than I have men, so I need to weight this appropriately to work out the correct proportions. The overall proportion taller than 1.83, which is essentially the same as saying those for whom the door frame will be too low. I'm going to do 19 times the proportion for women plus 1 times the proportion for men, and I'm going to divide by the number of parts in the ratio, so I'm back down at essentially considering one person, and the answer then is 0.0361.